Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we'll be looking at GCSE chemistry, cells and batteries. So, cells and batteries are essentially a way of harnessing all that energy that we can get from exothermic reactions, for example. So, once you get that energy from these reactions, you convert it to potential difference, voltage, and therefore you get electricity in a way. You get electric power. Using cells and batteries, we are converting from chemical energy to electrical energy. So today we'll cover what they are, how they work, and we'll look at some voltage calculations, how to predict voltages in particular cells. Without further ado, let's get started. So, first of all, here we have an electrochemical cell. Now, electrochemical cell is a basic system where we have two electrodes connected to each other in a closed circuit, two electrodes connected to each other, and electrolyte liquid essentially connecting them. So, electrolyte has to be a liquid that contains ions, that contains charged ions, because those ions will be carrying charge from one electrode to the other electrode. So, for example, a good electrolyte would be, sodium chloride. Because sodium in a solution, you have positively charged sodium ions and you have negatively charged chloride ions. So that would be a very good electrolyte. Now there are many other different electrolytes we could use as long as they produce charged ions in the solution, that's fine. And a way to predict what makes a good electrolyte compared to what makes a bad electrolyte is, one way to predict that is simply by looking whether any ionic bonding is happening. If there is ionic bonding happening, it will likely make a good electrolyte, whereas if there is no ionic bonding, most likely it will not make a good electrolyte. There may be some exceptions, but that's the rule of the thumb. So, that's our basic electrochemical cell, and that's what it is, very simple system. Now, what affects the voltage we actually get from the cell? Because different cells produce different voltages. Just like different batteries give you different voltages, which we will move on to later on in this lesson. But what gives those cells different voltage values? Now, one major factor that's affecting the voltage is definitely what electrodes are made of. Electrodes are usually made of metal, which conducts electricity. A material that conducts electricity, usually it will be a metal, and the main reasoning here, the main aspect that affects the voltage in electrochemical cell is what these electrodes are made of. Of course, we can make these from different metals, and usually, often we will have one electron made from one metal, one electron made from different metal, and it comes down to the reactivity of the metals. The bigger the difference between the reactivity of the metal, the higher the voltage is going to be, the higher the potential difference. So if we want to squeeze out as much voltage as we possibly can out of a cell, we would use one metal on one electrode that's not very reactive, and then on the other electrode we'll try to use a very, very reactive metal. So we're looking at creating the biggest difference in the metal reactivities. That's what will give a rise to biggest voltage. Now, another aspect that could affect the voltage, another factor is, of course, what is the electrolyte? Because essentially what is happening in an electrochemical cell is that we have a reaction happening. There is some reaction undergoing, and different electrolytes are contain different ions, and those different ions can react with different electrodes differently. Essentially, if we have different molecules involved, then simply we will get a different reaction. Simple as that. And that will give rise to different voltages. Now, important thing is that knowing what metals are these electrodes made of, we can often predict what voltage will that cell give us. So we'll be moving on to here. So of course, if we want to predict, first before we even go into this, if we want to predict what voltages we get from a cell, we have to assume that electrolyte is the same. So when we make any calculations here, we are assuming that these values that I got here are for this particular electrolyte of, say, sodium chloride, and that doesn't change between all these different cells we'll be discussing. So that's important. Having said that, knowing this, knowing that we have the same electrolyte in the cell, we can predict what different electrodes will give us, what voltage values we'll get from those different electrodes. So for example, here we have positive electrode A, negative electrode B, and the voltage we get from them. And here we have the sort of inherent potential difference values of all these different metals. These values essentially are used to calculate the final voltage of a cell we'll get here. And the way we calculate this is we get a value from a positive of a metal on a positive electrode, and we subtract from that, we subtract the value from a negative electrode, from a metal that makes up the negative electrode, and that will give us the final voltage. So, for example, we have iron here on the positive electrode, and iron here has a value of minus 0.40 volts, and here we have tin on the negative electrode, and tin has minus 0.10 volts. And therefore, using that equation, minus 0.4 minus 0.1, we get minus 0.3. So we just predicted a voltage of a cell that has iron on a positive electrode and tin on a negative electrode. And that's how we predicted the voltage. Now we can do that from grounds up like we did here, using these original values, original inherent voltage values for all these different metals at a particular electrolyte. So we can use those values to do that, but another way is we can use relative values. So knowing that we have iron and tin here at minus 0.30, and here we have iron and lead at minus 0.31. Now we are using the same, we have iron and the other metals here. So the common iron is the common one here. So any difference we get in these voltages must be down to the tin and lead, those different negative electrode metals. And what we are doing here is simply we are subtracting this one from this one. So minus 0.30 minus 0.31, we get the positive 0.01 voltage. If we use lead and tin, lead in the positive electrode and tin in the negative electrode. And that checks out because we have lead at minus 0.09 volts, and we have tin at minus 0.10 volts. So minus 0.09 minus 0.10 will give us plus 0.01. So this is, guys, the way we can predict all these different voltage values, and that's quite useful, especially if, say, we wanted to design a battery that runs at a particular voltage. I mean, this concept is used in the industry quite a lot, so this is a useful thing to know, guys. And That concludes our discussion on the electrochemical cells. However, what is the term battery? I mean, we know that battery is that thing that you put into electrical device and then we can run that electrical device for a set amount of time before that battery runs out, at which point we have to chuck it out or we have to recharge it. So, what is battery? So, we have electrochemical cells which give us that electric energy. They convert from chemical to electrical energy. Now, if we put couple of those electrochemical cells together, if we connect those few electrochemical cells together in series, we get battery. That's the definition of battery. So, for example, here we have electrochemical cell A, B, and C. And we connected them in series, and that gives rise to a battery. We created a battery. Now, we can calculate the voltages of batteries as well. The total voltage that the battery will output based on the electrochemical cells that constitute that battery. And because this is a simple connection in series, we simply add the values of the individual electrochemical cells. So, for example, here we have electrochemical cell A running at 1 volt, electrochemical cell B running at 1.5 volts, and electrochemical cell C running at 3 volts. So the total voltage, guys, will be A plus B plus C. So we have 1 plus 1.5 plus 3. And if we add those values together, you should get 5.5 volts. So this is a 5.5 volt battery. So this is quite simple compared to what we have been doing here. But that's how batteries work, guys, essentially. So now the final thing to discuss is non-rechargeable batteries versus rechargeable batteries. Now, when we're running these electrochemical cells, what happens is essentially a chemical reaction. We are converting from chemical energy to electric energy. So what happens is the ions in the electrolyte essentially are reacting with the electrodes. And therefore, we are gonna be using up the ions in the electrolyte, and we are going to be using up electrodes. Now, if we run out any one of these materials, the battery simply stops working. If we don't have any ions in the electrolyte carrying charges, simply we cannot run that electrochemical cell anymore. If we don't have electrodes, we cannot run electrochemical cell either. So any one of those components gone, the battery will simply stop working. And that's due to reaction undergoing and using up the reactants and creating products. So what's happening with the rechargeable batteries? Well, if we base our electrochemical cell on a reversible reaction whereby switching the direction of the current, we can sometimes reverse the said reaction and regain those lost electrolytes or regain those lost electrodes. And that's what makes the battery rechargeable, and which is an ability to regain those lost materials that we need to run our basic electrochemical cell. That's simply what rechargeable battery is. So this is it for today, guys. So the important thing here is probably the most challenging concept here is this part here, predicting the voltages. So make sure you guys practice this. If you have any questions whatsoever on this topic, please pop down a message in the comments. I will try to get back to you as soon as possible. Thank you very much for watching. I really appreciate when you guys watch my videos. This is why I love doing this. And if you want to stay updated on some more videos like this on biology, chemistry, physics and maths, and some biomedical science videos, hit that subscribe button below. Don't be shy. And if you think this video helped you, give me a thumbs up. Thank you again for watching. See you next time.